Hi, this is Kumaran. Today's video about searching a smallest number in 8085 microprocessor. In the series of assembly language programming of 85, we have completed already addition, subtraction, multiplication and division. So in that we are continuing that searching a smallest number in a given array. Let's start the programming. So for this, the input output tasks are the input is a array of numbers, which means n numbers will be given as a input. Out of that n numbers, which one is the smallest, that to be searched and given as output on the given memory address 43. So these are all the memory address we assume. If you want, you can take any address between 0000 to f of ff. So for that, I am taking this as address. Always the first number as length of the array in any input data. The first number should be that length of the array, which means that number of elements what we are going to give as a input. So the first one should not be a data, it should be a that count, how many numbers you want to give. So for example, in this sequence I have assumed that 4 number of data to be given. So here you have to give that 4 as length of the array. Now we have to give any number, so we can give E1, C2, 3, 4, 8, 5. So any number between 0 to f of you can give. So this is our inputs. So how it will be performed? The first thing is this to be taken as a count. So first what we are going to do is we are going to compare these first two elements. If you are comparing these two elements, the second one is smallest. So this should be taken as output between these two comparison. So on this comparison we will get the output as C2. So the next set is what we are going to do is this result and with the next number we are going to compare. So between C2 and 3, 4, the answer will be 3, 4. Then the between 3, 4 and 8, 5, next number will be compared. Between these two, the 3, 4 will be the smallest number. So finally the output should be 3, 4, that to be written on the output address 3, 4. Okay, this is the logic what we are going to perform in this. So count how many comparisons we have done between E1 and C2 one comparison, then C2 and 3, 4 next comparison, 3, 4 and 8, 5 third comparison. So we are, even though we have 4 elements, but only 3 comparisons. So that's what if we have n number of elements, we will have only n minus 1 comparisons. That's why whenever we get the count, then decrement once, because for the n inputs we have n minus 1 comparisons alone. That's the logic behind taking the count. So we don't know what count, what number of data is there. That's why we will write a program for the general data. Suppose n elements means we have to consider n minus 1 comparison. So get the count and decrement once straight away. Then we have to take the first element on the accumulator, second element on the memory, both will be compared. Suppose no carry means we have to take that the smallest number into the accumulator. So that's the logic involved in this. So let's start the programming. Till now all the program we have done with the direct addressing. Whenever we have to handle a string of elements, consecutive memory locations, then we have to use that indirect addressing. So indirect addressing means load the address into the HL pair, then use that letter M, memory. So that's the indirect addressing. So for that we have to initialize this address, the starting address with the HL pair. So the 4200 is a starting address that to be loaded with the HL pair. To load the any register pair, we have that instruction called LXI. LXI H comma the corresponding address. This is what the instruction. Whenever we need to load that 16-bit immediate, LXI means load the register pair with the immediate data. So HL pair will be loaded the immediate data 4200. So when you type in simulator, always we have to use that X to represent hexadecimal. So the initialize. Now the first element is count, that to be taken any other register except that accumulator. So we'll take for example a C register. I am taking that. So use that move C comma M. So C comma M means it's indirect addressing. M means it address given by actual pair. Then that data, that address will give you the data. For example, in this case, the 04 will be copied to the C register here, because whenever M is referred, it will refer HL pair. HL pair will give you that address 4200. That address will give you one 8-bit data that will be copied here. So here for n data we have n minus 1 comparison. So straight away decrement this C register DCR C. So the count initialization and decrement is over. Now we have to get the first element. So for that the HL pair currently pointing 4200, but we need to get data from 4201. Then we have to use that increment H. Otherwise you can use LXI H comma 4201 also, but it is not advisable because program size will increase. For in that efficient programming, we are increasing this HL pair by 1, INX H. So now the HL pair is pointing that 4201. So now we will take this element to the accumulator with the help of move instruction, move A comma M. So from the memory the content is copied. Memory is HL pair pointing that 4201 now due to that increment. So to get the next element, again you increment. This is what we will do, INX H. So now the first element in accumulator, second element in memory, directly you can compare CMP compare M. Compare M means what it will do, that it will subtract that A minus M, only flag updated, either flag register updated. So neither A nor M will be updated here. So that's the difference between compare. Subtract means A minus M, answer will be in A, but compare M means A minus M, only flag gets affected. Now we have to check the carry flag. Suppose carry occurs. Carry occurs means what? Carry occurs means whatever number in the accumulator itself, the smallest number. So no need of exchange, go to the next. Suppose carry occurs means we have to go to the next. Suppose no carry. No carry means the accumulator have the largest number. In this case, E1 is the largest, C2 is smallest. So what we have to do? C2 as the smallest number we have to take into the accumulator. So whenever we write a program with the conditional jump, the next instruction to be, if condition not satisfied, what we have to do? So if condition satisfied means if carry occurs, go to the next. Suppose no carry means we have to exchange whatever available on the memory to be copied to the accumulator. So use that move A comma M, because M pointing that C2 now, that to be copied to the accumulator. So the one comparison over, result also taken into the accumulator now at this point. So what we have to do? We have to check the count now, decrement the count once, and check that whether it is 0 or not. So we decrement once DCR C. Suppose no 0 means jump on no 0. Repeat this process, we have to repeat number of times. Where that repeat will be, So we have to get the second number and compare with this. So here, because already accumulator we have a smallest till the result. Now repeat means what will do? It will, so currently that HL is 4202, we are incrementing 4203, then compared C2 with 34. Again this process will repeat until that C is 0. So whenever C is G count is 0 means we have compared all, the result is available on accumulator by this stage. So what we have to do is, we have to store the result on 4300. That's what assumption we had. So if you want, you can use any other address also. To store the accumulator, we'll use that STA, the address 4300H. So at the end of this program, we will get the output at this number 4300 as 34. So this is the searching a smallest number. So you can have a doubt that for largest number what will have a change. Largest number means only that algorithm changes in this, because when you compare these two number, if no carry means the number is already largest in this. If carry occurs, then only we have to exchange. So here instead of JC we will use JNC. That's the only change we have for largest number of a given array. That's the only change. Otherwise it will be the same in this. Okay, that's about program for searching a smallest number in a given array in 8086 microprocessor. So that's all about the program. Let's go back to the simulator. Go to the simulator and complete our program. So for 8085 we have a simulator kit, microprocessor 85. So open this. Let's type the program. So LXI H, here no comma, only that space in the simulator. So the same program we will use move C comma M, then directly you decrement C, DCR C, then we have to get the next element INX H, get the data to accumulator. Now we increment the next one to point out the data to. Now compare CMP comma M. So we have to use JC next. Suppose no carry means go to the next. Otherwise carry occurs, get the data from memory to accumulator. Move A comma M. So the next label should be here. In this case we have to decrement the count to check whether it is completed or not. JNZ repeat label. So store the answer STA 4300, then fault. So one more thing is here the label jump no 0 repeat, the repeat should be here the increment H. So this is the program. Now we will give the input 4200. We have to give that count as 04 what we given. Then we given that E1, C2, 3485. So these are all the number we given. The output address we have to initialize with the 00. The output address 00, that 4300 output should be 00. Okay. Now we will compile this program. So yeah, program is compiled, no error. The input is given. Check one by one. We will know that HL pair is loaded with the 4200 now. Get the data to C. Look the C register now 00. The next one you will get 04 here 04. Now the HL pair is incremented. Yeah, it continues run. It completed that all the comparison. Result is return 3 4 as output. This is what the continuous run. Otherwise you can give step by step also for your understanding. You can run one by one how it is, whether carry occurred or not, everything you can check by sequence. That's about searching smallest number. The same program we can go with largest number also. Instead of JC, we'll go with JNC. For the same input, what we'll do, we'll check. See here the program. We will check one by one. The 0 4. The first one is C is loaded with count, incrementing H, M comma A, accumulator taken the first number. We are comparing both. See, by this time no carry. No carry means no carry means it will jump. It won't execute A. So it will jump here, decrement C. It will decrement no 0 means it will go to the repeat, increment, next one compare. Because out of this number E1 is the smallest, so it won't execute move A comma M. So it will repeat until C becomes 0. So now C becomes 0, it will store the result here E1 in the accumulator. Okay, that's all about the searching a smallest number or largest number in 8085 microprocessor assembly language program. I hope it's clear. If you have any clarification or doubt, you can comment on the video. I will answer later. So thank you.